Welcome to this lesson on valence electrons. Valence electrons are some of the most important concepts you'll learn in chemistry because they explain how atoms interact with each other. These special electrons are the key to understanding why certain elements bond together and why chemical reactions happen the way they do. By the end of this video, you'll have a clear understanding of what valence electrons are and why they matter so much in chemistry. So what exactly are valence electrons? Valence electrons are the electrons located in the outermost shell of an atom. Think of an atom like layers of an onion, with the nucleus at the center and electrons arranged in shells around it. The electrons in that outermost layer are your valence electrons. These are the electrons that participate in chemical bonding. When atoms form compounds or react with each other, it's these outer electrons that are doing all the work. The electrons closer to the nucleus stay put, but the valence electrons are the active participants in chemistry. Let's visualize the electron shell structure. Imagine an atom with multiple shells surrounding the nucleus. The nucleus is at the center, marked with letter N for nucleus. Around it, you have several concentric shells. The innermost shells hold electrons that are tightly bound to the nucleus. But the outermost shell, the valence shell, is where the valence electrons reside. In this example, you can see the outermost shell highlighted, showing the valence electrons. These outer electrons are further from the nucleus, which means they're less tightly held and more available to interact with other atoms. Now you might be wondering, why do valence electrons matter so much? There are four main reasons. First, they determine chemical bonding. Valence electrons decide how atoms bond with each other to form molecules. Second, they control reactivity. The number of valence electrons tells us how reactive an element is. Third, they govern compound formation. They decide which compounds can form and which combinations are stable. And fourth, they define chemical properties. An element's behavior, its reactions, and its characteristics are all determined by its valence electrons. Without understanding valence electrons, we can't predict or explain chemical behavior. Let's look at some examples to see how we find valence electrons. Take carbon. Carbon's electron configuration is 1s2, 2s2, 2p2. The highest energy level here is level 2, and if we count the electrons in that level, we have 2 electrons in the 2s orbital and 2 in the 2p orbital, giving us 4 valence electrons. Oxygen has the configuration 1s2, 2s2, 2p4. Again, level 2 is the outermost, so we count 2 plus 4, which equals 6 valence electrons. Sodium has 1s2, 2s2, 2p6, 3s1. The outermost shell is level 3 with just 1 electron, so sodium has 1 valence electron. The pattern is clear. Count the electrons in the highest energy level. One of the most important concepts related to valence electrons is the Octet Rule. The Octet Rule states that atoms want to have 8 valence electrons. This is because having 8 valence electrons creates a stable, low-energy configuration. Noble gases like neon and argon already have 8 valence electrons, which is why they're so stable and unreactive. The exception is helium, which is stable with just 2. All other atoms try to achieve this stable octet by gaining, losing, or sharing electrons. This drive to achieve 8 valence electrons is what drives all chemical bonding behavior. When you see atoms forming bonds, they're trying to reach that magic number of 8. Valence electrons participate in 3 main types of bonding. First is ionic bonding, which occurs between a metal and a nonmetal. In ionic bonding, one atom transfers its valence electrons to another atom. The metal loses electrons and the nonmetal gains them. Second is covalent bonding, which happens between 2 nonmetals. In covalent bonding, atoms share valence electrons with each other. Both atoms get to count the shared electrons toward their octet. Third is metallic bonding, which occurs between metal atoms. In metallic bonding, valence electrons form what we call an electron sea, where electrons move freely between all the metal atoms. Each type of bonding is driven by the desire to achieve a stable valence electron configuration. Let's review the key takeaways from this lesson. First, Valence electrons are the electrons in the outermost shell of an atom. Second, they determine chemical bonding and reactivity. The number and arrangement of valence electrons controls how an element behaves chemically. Third, atoms want 8 valence electrons for stability, and this is called the Octet Rule. And fourth, understanding valence electrons explains how and why chemical bonds form. Whether it's ionic, covalent, or metallic bonding, it all comes down to valence electrons. Master this concept, and you'll have a solid foundation for understanding all of chemistry. Thank you for watching.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.